countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay. Hello everyone. Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please recite your prayer according to your religion. Amin, amin, ya Rabbal Alamin. Okay, how is everyone today? Okay, my prayer that everyone is doing fine and ready to proceed with today's class. I am Cikgu Hapsah Ayu from SMK Sultan Sulaiman, Kuala Terengganu, your moderator for today, and together with me is our control host, Cikgu Nun from College Matrikulasi Negeri Sembilan, our observer Cikgu Naini from SMK Sultan Sulaiman, Kuala Terengganu, and our important person of the day, our presenter, Madam Rosmaya from SMJK Yuhua Kajang, Selangor. Okay, for the record, we are now live on Madam Rosmaya channel. So, as a sign of support to Madam Rosmaya for her hard work in preparing today's lesson, please subscribe her channel, not forgetting ours too. As usual, the lesson will last approximately for 1 hour, and please follow the class up until the end and give your full cooperation in making this session a lively one. Please take note that certificate link will be given at the end of this session. Besides this, don't forget to claim your credit for today's live class. Collect the credit to redeem the attractive prize in store. The link to claim the credit and the presenter username will also be given at the end of the session. However, please be alert to a letter and 5-digit code to claim your credit that will be announced 1 digit at a during the live class. Okay. So, get ready with your pen and paper. I would like to remind students to use suitable language and profile picture if you wish to post comment on the chat box. I'm pretty sure all of the students here are excellent students who will uphold positive classroom environment. Okay, students, stay focused, and if you have any question, please write on the chat box and Madam Rosmaya will try to provide you with the answer. Okay, before we start, okay, this is a letter and the first quote for today. Okay, we have A10. A10, Okay, so without further ado, please welcome Madam Rosmaya.
Okay, hi everyone. Okay, so thank you to our moderator, Cikgu Hapsah Ayu. Okay, I'm a form 6 teacher, okay, Madam Rosmaya, SSMJK Yuhua Kajang, Selangor. And before we start, okay, I would like to announce that okay, now you all can download Academy YouTuber apps already. Okay, so for those who doesn't know yet that we have a academic YouTuber apps. So you can just search at the Play Store. Okay, then you type the academy YouTuber and download from there. Okay, there are many PDPC videos and then free tuition online class, the past tuition online class and a lot more. Okay, it will be much easier for you to do the searching by just using your fingertip only. Okay. So for those who are new here, I also would like to introduce the pre-U teams in Academy YouTuber. Okay, so the pre-U teams is a collaboration team from STPM and matriculation. Okay, so with us today, okay, this is a physics team. Okay, I'm the leader. So physics teachers here in this Conti is teacher known as a control host and our moderator, teacher Ayu. And we also have together with us teacher Naini from bio teams, right teacher Naini? Okay, from bio team. Okay, so the maths team lead by teacher Im. Okay, then biology team, can you see teacher Naini there? There teacher Naini, and she is with us today. Okay, this is biology pre-U team. Okay, lead by Cikgu Faiza. Okay, so next is chemistry team lead by Cikgu Shahnon. And account and economy pre-U team lead by Madam Fizi. Okay, besides that, we also have STPM team. STPM team like pengajian am, MUED, pengajian perniagaan and perakaunan. Okay. Okay, so now our discussion for today. Okay, so what is our discussion for today? So our discussion is we are going to solve problems on gravitation. So the questions given already in the description part, okay, below this video, okay, this stream, our live class today in the description part, and also I posted in the chat box there the question PDF for you to download to refer the question. So those who have downloaded and do the question, okay, very good. So we will discuss and check your answer whether they are correct or not. Okay, so in our objective for today, okay, you will be able to learn the strategies in solving the gravitation problems. Okay, so the formula there are many formulas for this topic, but at the moment we are going to concentrate in this video, okay, in this class for this five formula, okay, five formula. There are a lot more actually, but for today's topic, solving problems, we are going to we are going to use this equation, this formula. So F equals to G M per R squared. Okay, capital letter, small letter to represent the two masses of object. Then the electric field. This is force and gravitational field. So this is the gravitational field. This is the gravitational force. Not electric field. Okay, so this is the gravitational field. Gm per R squared. Okay, R is the distance between the two objects. And U is the gravitational potential energy. The formula is negative GMM per R. And the gravitational potential formula equals to negative GM per R. And this is the gravitational field G prime on the latitude and on the Earth, Earth surface. For the North Pole and at the equator given by G plus minus R omega squared. So depends the G given in the question. Okay, so let's start with the first question. Okay, so to those who have done the questions, you can write there in the chat box and we can check later whether your answer is correct or not. So do not worry to make mistakes because learning by mistake is more what you call that means what you call that? Lebih baik, right? Better learn from mistake. You can remember it, memorize it. It can bear in your mind for quite a lot, for a long time. Okay, so first question 1. We read the question first. The radius and density of a planet are respectively half the radius and half the density of the Earth. So what is the weight of a boy on the surface of the planet if his weight on the surface of the Earth is 2000 Newton? Okay, so you are given radius and density. Okay, so one is half of the other. Okay, same as the density of the Earth. So the formula we are going to use is gravitational force, because you are given weight. So weight is given, weight is gravitational force. So the formula is gmm per r squared. That's why we use this formula. Okay, then because density is given, so we are going to use the formula for the density, which is mass per volume. So the mass equals to density times volume. Okay, so the volume, we can assume that the planet is a spherical shape. So we use formula for volume 4/3 pi r cube. So these three formulas we are going to use in the equation. Okay, so now let's substitute the values given into the gravitational force equation. Okay, so for Earth is 200 Newton, okay, equals to G is gravitational constant, and then M, rho, V, rho is the density, volume, per, let's say the radius of the planet is R, okay, R squared, capital letter, we use capital letter R. You substitute the volume 4/3 pi r cube. Okay, so now we can cancel out r squared here. So this one r cube, so leaving one r there. Okay, so you simplify, you get gm rho 4/3 pi r. So this is first equation for the planet Earth. So next is the other planet. So the other planet, you use the same formula, but the density now is half. So you write here half rho. Okay, half rho. 4/3, and the radius is half. Also here you put half r. Half r. Don't forget cube there. And the distance r here is half of the radius. Again here half of the radius of the Earth. Okay, don't forget square. So common mistake students make always, they forgot to write the square. The square here for the distance. Okay, so now we simplify this equation. So we cancel out the half r. Half r squared. Here another half r squared. Leaving only half r. Okay, so the rest is, okay, so that's all. No more to what you call that, to cancel out. So leaving this one. Okay, so now to find the weight of the boy on the surface of that planet that we don't know, so we can use ratio. Okay, equation 1 to equation 2. Okay, equation 1 divided by equation 2. Okay, so equation 2 divided by equation 1 also can. So this one got typing mistake here. So what I do here is equation 2 over equation 1. So f prime per 200, and then here this one divided by this the equation 1. Okay, then you cancel the constant. Okay, the density and what else? The 4/3 pi. Okay, cancel everything. R also, R. Okay, now 1/2, and we have another one 1/2, so we have 1/4. And cross multiply, so f prime is 200/4. So the answer is 50 Newton. So when the boy is on the surface of this planet, so the weight of the boy becomes 50 Newton. Okay, less than on the Earth. Okay, so any problem on this one? So hopefully no problem. If got any problem, you can write there in the chat box. Okay. So you don't need to put negative here. Okay, some books use the equation, they put negative. The negative in the equation just to show that the force is the attraction force. Okay, so we have two kind of force, attraction force and repulsion force. So for attraction force, usually we use symbol negative. For repulsion force, we use symbol positive. So that's why some books use put negative there, because of the gravitational force is always a attraction force. Okay, so next we go to question 2. Okay, question 2. So we read this question. Okay, calculate the gravitational field at point O due to 3 masses. So we have M1, M2, M3. Okay, whose positions are shown below. Okay, you can imagine this is a planet. Okay, so if the masses M1 and M2 are equals, so what is the change in gravitational field at the point O? Okay, so we are going to do question A first. The gravitational field at point O. Okay. So gravitational field equation is given by Gm per r squared. Okay, memorize this formula, Gm per r squared. Okay, so there are 3 masses here, M1, M2, M3. So electric field, sorry, I keep on saying electric field, actually gravitational field. So electric field you learn in SEM 2. So for SEM 1, you learn gravitational field. So gravitational field by mass M1 is in this direction, from position O here. So you draw the direction of electric field by mass 1, okay, and represent by the letter E1. E1. So E1 is equals to Gm1 per A1. So we substitute the distance from O to M1 given A. So you substitute the distance A there. Okay, so now the E2 is the gravitational field, okay, by the mass M2, okay, by this planet mass M2. So electric field, so I keep on saying electric field, gravitational field, okay, so the gravitational field is towards the M2, the direction. Okay, so you form the E2, okay, substitute all the values into the formula here. So we get E2 equals to Gm2 per A squared. So we do the same for mass 3. So for mass 3, electric field, gravitational field, sorry again. So the gravitational field is towards the M3. So you get E3 equals to Gm3 per A squared. So all distance is the same, A from the O, position O here. Okay, so now the resultant electric field as gravitational field, okay, the resultant of gravitational field, we total up, we use vector method, okay, we use vector method. So we total up the gravitational field along x direction and gravitational field along y direction, okay. So along x direction, we have E1 and E2. Okay, E1 and E2. So E1 minus E2. So we use negative sign for the E2 and E1 for the positive sign, follow the x direction. So we get EX equals to E1 minus E2. So you can substitute the values here, E1 and E2 here. Okay. So EY, okay, we have gravitational field vertically by E3, by E3. So the EY is only got one, E3, okay? Because M1 and M2 supply the electric field by M1 and M2 is horizontally, so one only from vertical component for the gravitational field, which is equals to E3. So now you substitute this into here. Okay, then we can find the resultant electric field, gravitational field. So the resultant gravitational field, okay, equals to square root of EX squared minus EY squared. Okay, EX squared minus, so this one supposed to be plus, okay, this one supposed to be plus. Okay, my typing mistake there. So EX squared plus EY squared. Okay, so you just change the S plus. Okay, actually E1 and E2 can be also in this direction if E2 larger than E1. So it depends. So not given here the exact value. So EX can be this way also, depends on which one is larger. Okay, so now you substitute the values just now, EX and EY, into the equation. Okay, remember this one is supposed to be this one minus, correct? This one is plus, okay? Typing mistake there. So this one plus, okay? And this one minus, you substitute into here. And you can simplify to get the gravitational resultant, gravitational field resultant. Okay, factor out G, A squared, and then the G here. So the G is G squared there. So square root of G squared is G. And A squared there, 1 per A squared, squared again, A squared squared. So square root of A squared squared, we get 1 per A squared. So you can simplify to get the gravitational resultant. Okay, so now for the B question, done for A. Okay, for B, if the masses M1 and M2 are equal, so what is the change in gravitational field at the point O? Okay, now M1 and M2 is the same. If not the same, it either this one or the bottom one. So we don't know which one is larger, right? So what we do just now is we assume E1 is larger than E2. Okay, so now the question B, they are equal in magnitude, M1 and M2. So if they are equal in magnitude, what happened? M1 minus M2 will be 0. So the E resultant will be only equals to EY. So gravitational resultant, gravitational field resultant is equals to EY. Okay, so which is equals to GM3 per A squared. Okay, not? So any problem, if got problem to understand, you can write there in the check box. Okay, so looks like no comment from there. Okay, so we can continue with question 3. Okay, so we go to question 3.
Okay, madam.
Yes.
Okay, madam. Can
okay.
We share the third code? Okay.
Third code or second
code?
Second code, right? Second code.
Second code. Second code is number 0.
Okay, 0.
Okay.
Okay, jot that down. Okay, for claim your credit. Okay, so we continue with question 3. Okay, so if the masses and mutual distance between the two objects are double, so what is the change in the gravitational force between them? Okay, so the question asks for gravitational force. So we use this formula. Okay, F equals to GMM per R squared. And for the first equation, okay, F1 equals to GM1 M2 per R1 squared. This is first equation. Then now for the first situation, for the second situation, the two objects now double. The distance, the masses double and this distance also double. Okay, masses double, distance also double. So we form another equation, but this time with the mass double. So from M1 becomes 2M1. From M2 becomes 2M2. Because both of them, the mass are doubled. So 2M1, 2M2. And then distance also double, 2R1 bracket squared. Okay, so very easy actually. You just need to understand what is given in the question, information given. So everything is double. Okay, next you substitute the you complete 2 times 2 is 4, so 4 GM1 M2 divided by 2 squared is 4, 4R1 squared. Okay, now compare, you can cancel the 4, so you get GM1 per M2 per R1 squared, which is equals to M1, which is equals to F1, which is equals to F1 because GM1 M2 R1 squared, right? So that means the answer is no change in the gravitational force between them. So if you double everything, no change in gravitational force when masses and distance are double. Okay, so I can see that Cikgu Faiza. Okay, welcome Cikgu Faiza to physics class today to support our physics class today. We have teacher Naini here, Cikgu Faiza. Okay, so we go to the next question. We read first the question. Question 4 now. An unknown planet orbits the sun with distance twice the semi-major axis distance of the Earth orbit. Okay, so this is unknown planet. So it's twice the distance. So the Earth period is given as T1. Okay, T1. So what is the period or time period of this unknown planet? Okay, so we are going to find the period for this unknown planet. But we know that the distance is twice the semi-major axis distance from the sun. From the sun, they both orbiting the sun. Okay, so now we use force equals to GMM per R squared. Okay, because this is a period and they are orbiting the sun, so that means we use centripetal force. So I use symbol Fc to distinguish between this gravitational force. Okay, so Fc means centripetal force given by mr omega squared because they are orbiting. So we assume that it's a circular motion. Orbiting the sun in circular motion. So we use centripetal force equals to mr omega squared. So we are going to combine these two equations. So the centripetal force is provided by the gravitational force. Okay. So GMM per R squared equals to mr omega squared. Why? Because the centripetal force is provided by the gravitational force. So they combine this question in chapter 6 here to chapter circular motion. Chapter gravitation and chapter circular motion combined together. Okay, so you can cancel the m and you get gm per r cube equals to, so omega r here cross multiply, so you get r cube. So omega, this is angular velocity or angular frequency. Okay, so omega is 2 pi per t, 2 pi f or 2 pi per t, bracket squared. Don't forget the squared there. So t is the period. Okay, so you can substitute the t1 into here. Okay, so in this case, okay, we put together all the constant to one side. So 2 pi, 2 is constant, pi is constant, right? So 4 pi squared, we bring to the left side, all the constant here, and all the variables, r is variables and t is also the variables. So we put on the right side. So we arrange the equation like this. So gm 4 pi squared is a constant. So this is actually Kepler's law. Kepler's law. So therefore, we can form equation. We can use variation method. You can use simultaneous equation method or you can use variation method. It's up to you. Like what we've done before in the previous solution, we use simultaneous equation method. So in this time, for question 4, we use variation method. So that's mean r cube per t squared is always constant because gm per 4 pi squared is constant. So this ratio is always constant. This is from Kepler's third law. So you can write as R1 cube per T1 squared equals to R2 cube per T2 squared. Okay, the ratio is always the same. Okay, so now we can substitute the T1. This is T1, substitute already. And then 2R1 bracket cube T2 squared. So what we are going to find is T2. T2. R2 is double, right? The distance double. So you substitute there 2R1. Okay, then 2 cube is 8. 8R1 cube. Cross multiply to get T2. Cancel R1. R1 cube. So T2 is 2 set to T1. So this is the period for the unknown planet. Okay. So
Okay.
That's for the question 4.
Okay, madam. Okay.
Okay.
Can we take a break for
Okay, we
advertisement?
take a break now.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay. Can continue.
Okay, welcome back, student. Okay, thank you, Madam Ayu. Okay, so now we continue with question 5. Okay, we read the question together first. The figure below shows 3 identical objects, each of mass m, okay, that are placed at the vertices of an equilateral triangle with sides of length x. Okay, what is the total gravitational potential energy of the system? Okay, this time we are going to find the gravitational potential energy. So to use this equation, okay, the equation is U equals to negative GMM per R. So you must bring along together the sign, the sign negative. Okay, don't ever leave the negative sign here. So U equals to negative GMM per R. Okay, so for the gravitational potential and total gravitational potential energy, so that's mean we total all the energy U1 plus U2 plus U3. We have 3 masses here, all have same mass. So U1, U2, U3. So you substitute the values, all same values actually, m. Distance between these two m also x, and the mass, their masses also m, so becomes m squared. U2 also same, negative gm squared per x, and for the U3, negative gm squared per x. So any combination, all the possible combination of the energy from the two masses, these two m, and these two m's. Okay. Okay, now the total of energy will be U1 plus U2 plus U3. Okay, so you substitute everything here. Okay, don't forget, bring along the negative. Then you get negative 3 gm squared per x. Okay, so this is the answer for the U total. Okay, so the negative here means that if the one variable increasing, so the other variable is decreasing. So that is what is negative, because U, gravitational potential energy, means the work done to bring the object from, or the planet or any mass from infinity to the point near the other planet, the object to the planet. Okay, work done. So from far away, U is considered as 0. So when you bring the object or the mass to near the planet, any planet, so what happened? The U increases, but the distance decreases, right? Because nearer to the is near to the planet. So as X increases, U decreases. So that's why we have negative there. Yeah. Okay, so now we go to question 6. Okay, so we read this question. The period of simple pendulum at the equator is 1.0 second. So what is the period of the pendulum at the North Pole? Okay, radius of the Earth is given 6.4 times 10 to the power of 6 meter. And then given here 1 day equals to 8.6 times 10 to the power of 4 second. Okay, this is for the Earth. Okay, not mentioned here, but supposed to mention here. So the Earth period, rotation of the Earth 1 day equals to 8.6 times 10 to the 4 second. So the G value, this is G of the Earth, right? So G is 9.81 meter per second at the North Poles. So here at the North Poles, Okay, so this is the pendulum, simple pendulum. So the period for the simple pendulum is given by this equation. This is question you've learned in form 4, form 5 already. So T equals to 2 pi square root of L per G. Okay. So at the North Pole, so we are going to determine period of the Earth rotation at the North Pole. Okay, so this T is not the same as this T. This T is the T for the simple pendulum, whereas this T of the simple pendulum at the North Pole will be different. Okay, so we are going to find using this equation, T at the North Pole. Okay, so now T at the equator for this simple pendulum is given already 1 second. Okay, so we are going to use this T. Okay, so G at the North Pole is given 9.81 meter per second. Okay, so you write there. Okay, this is G at the North Pole. But G at the equator, we don't know, not given. So you need to find the G at the equator first for this G. So remember that the G primes, the formula is given by G plus minus R omega squared from the equation. But for G equator, the G must be less than the G at the North Pole. Because we know that in reality, the Earth is not exactly the spherical shape. So the Earth actually the ellipse shape, like this one, ellipse shape. So the radius here, distance from the center of the Earth is shorter, less than if the object on the at the equator here is longer distance. So therefore, the G at the North Pole will be greater. So from this 9.81, so the G equator must be less than 9.81. So that's why we minus R omega squared. So the difference from the North Pole and the equator is by R omega squared. So that's why you minus. You cannot use plus. If you plus, you get larger value than 9.81. So it's not possible. Okay, it's not possible, not logic. Okay, so now we use this equation to find the G at the equator. G minus R omega squared. Okay, so now you substitute R is 6.4 times 10 to the 6, 2 pi, and then T of the Earth is given here in second. 1 day equals to 1 second. So substitute everything given here into the equation. So you get G at the equator is 9.78 meter per second. You see, compare these two. So the G equator is supposed to be less than 9.81. I repeat, why? Because the distance from the center at the equator is larger. Okay, so that's why the G at the equator must be less. Okay, so now after you get the G, you can substitute into the equation of the period for the simple pendulum. Okay. So T is directly proportional to 1 per square root of G. You can form two equation and solve using simultaneous equation, or you can use variation method. So it's up to you. So this time I'm going to use the variation method because 2 pi and L is the same thing. Because the same simple pendulum we put at the equator and we put at the north pole. So 2 pi and square root of L will be the same. So the changes is only in T and G. Okay, T and G. So you write this and equate, put equation and cancel all the constant. So only the variables used here, T1 per T2 equals to, because this is inversely, so you put square root of G2 per square root of G1. Okay, square root of G2 per square root of G1. So this method, we use the variation method you've learned in maths, form 5. Okay. Okay, so now substitute T1, 1 second. T2 is what we are going to find at the North Pole. Okay, G2 is 9.81, okay, at the North Pole. And T1 G1 is 9.78. Okay, so you solve for T2, the answer is 0.998 second. Slightly a little bit difference in period. Not much different, right? 0.998 second. Okay. So, done for question 6.
Okay.
So, now we go to question
Madam.
7.
We,
Yeah. Oh, it's time for code.
okay, Madam. We share
Yes.
for the third code. Okay, third code is number 2. Number 2.
Okay. So, write that.
Okay.
Write that in your paper to claim credit. So, one more code to collect. Okay, so we go to question 7, and in the chat box there, I can see Teacher Im too. Thank you, welcome Teacher Im, and thank you for joining the physics class today. Okay, so Teacher Im is from Maths, pre-U teams in Academy YouTuber. Okay, so let's read the question 7 now. Okay, a body is released from rest from a height 2r from the surface of the earth. So r is radius of the earth. So derive a formula for the speed of the body when it reaches the earth's surface in terms of r, and then mass of the earth m, and the universal gravitational constant g. Okay, so you imagine this is the object or a body released from the rest from the height of 2r. So that means the radius is r, then the height is 2r. So you measured from the center of the earth is 3 r's actually. 3 r's. So 2r is from the surface. So must be very careful. Okay, what question given? So 2r is from the surface of the earth. So from the center of the earth will be 3 r's. So derive a formula for the speed. So mention speed here, so you can use principle of conservation of energy. We use principle of conservation of energy because we are going to find the speed. Okay, principle of conservation of energy state there, no energy loss. Okay, total of energy is always constant if no energy loss. So total the energy loss is by any other, but is you just add into the energy is always constant, so it only convert from one energy to another energy. So that is why the loss of energy comes from. But actually, the energy is always constant all the time. Okay, so now we use gain from the principle of conservation of energy. So gain in kinetic energy is equals to loss in potential energy. Okay, so where this comes from actually? Okay, so we know that principle of conservation of energy said that total of energy always constant. So at initial position, So kinetic energy equals to potential energy at initial. So Ki, we use symbol as Ki plus Ui. Okay, when it reach the ground here, so Kf plus Uf, potential kinetic final energy plus kinetic energy final plus potential energy final. Okay, so you can form this equation. Then if you okay, so then if you rearrange the equation, so Ki minus Kf on the left side, and then another one Uf minus Ui. So what you get from here? We get change in kinetic energy, and on the right side we have change in potential energy. So it can be gain in kinetic energy or loss in potential energy, or it can be loss in kinetic energy or gain in potential energy. Why? Because you can also arrange like this. Okay, so if you bring Uf to the right side, it's become Ui minus Uf. And then for K, you bring to the right side, it's become Kf minus Ki. So it's the same thing actually, whether you get it gain in kinetic energy or loss in potential energy, or a loss in kinetic energy equals to gain in potential energy. So it depends on the situation given. Okay, so at the at final answer, we still get the same answer. So in this case, we use gain in kinetic energy equals to loss in potential energy. Why? Because as the body is released, so it will lose its potential energy. And from the release from rest here means kinetic energy becomes from initial is 0, then it gain kinetic energy, because when you release, what happened? The body moving and increase in kinetic energy. So that's why we put here as gain in kinetic energy, and potential energy is lost in potential energy. Okay, so now half mv squared minus 0. So the v is the speed of the body when it reaches the Earth's surface. Okay, when it reaches the Earth's surface. Okay, then minus 0. Then for the loss in potential energy, okay, there are two positions here. Okay, on the surface and from the 2r, from 2r distance from the surface, and on the surface here. So potential energy here, we use gravitational potential energy, and must be very, very careful. The potential energy, gravitational potential energy is measured from the center of the Earth. So the center of the Earth to the object, the body will be, this distance will be 3 hours. This is where the student always make mistake. Common mistake student makes every year. Distance for the gravitational potential energy, okay, must be always measured from the center of the planet, or in this case is the Earth. So that's why 3R. Okay, 3R. GMM is the same thing, the two object here. Body, the body and the Earth, GMM. So bring along the negative sign, because this is gravitational potential energy. So in the formula, it has the negative sign. Okay, so for on the surface, the distance from the center will be R here. So at the surface, GMM per R. Okay. So UF first minus UI. Sorry, so which one we use? UI. So UI minus UF. Okay, UI minus UF. We use this one. We use this one. UI minus UF. So KF minus KI. If you want to use above, also the same. You still get same answer. So it doesn't matter. So it doesn't matter. Okay, so now equate the denominator here. So times 3 times 3. So you can simplify this as, so minus 1 plus 3 becomes 2. 2 GMM per 3R. Okay, then you cross multiply the 2 here, cancel the M, cross multiply 2. So you get 2 times 2, 4 GM per 3R. So this is the speed of the body when it reaches the Earth's surface. Okay, So check the terms that are asked to be written in. So R, M and G. So all together R, M, G. Okay, written in the terms R, G and M already. So this is the answer. Make sure every symbol you substitute, use what is given in the question. Okay, so done for question 7. Okay, if you got any question, you can write there in the chat box. Okay, so no one write there. So I know SEM 1 is quite a tough topic. So the most every year, compare SEM 1, SEM 2, SEM 3. So usually SEM 1 result is the not so good compared to SEM 2 and SEM 3. Actually, it's but I hope it's not bring down your motivation down, but don't forget you practice make perfect. So practice a lot so that you don't get too what do you call that from the actually it depends on you all actually, right? Depends on you all. Okay, so remember, practice make perfect. So practice a lot. Even though you make mistake, but still continue doing, because learning from mistake is better compare if you don't do it at all. Okay, now we go to question 8. We read the question. Two bodies of masses m and 4m are placed at a distance r. Okay, calculate the gravitational potential at a point on the line joining them where the gravitational field is 0. So we don't know where in between these two masses, M and 4M. But somewhere in between here, the gravitational field is 0. Okay, so now we assume that we use symbol D for the distance at that point. We don't know this point, where is it from? So we just assume it's D. So therefore, the remainder of the distance here will be R minus D. So D is what we are going to find, the D value. R is given. Look at the question, distance R. So R is given. D is not given. D is what we are going to determine now. Okay. So using the gravitational field equation, E equals to gm per R squared. Okay, so you form two equations, which is E from M and E from 4M. So E from M, the gravitational field by planet M here. So we name as E1. So you write gm per D squared. Substitute this M into here. So for planet or for bodies 4M, we name as E2. Okay, so the gravitational field by this 4M, mass 4M. So we write as E2. So becomes G, mass is 4M per, okay, distance. Distance is R minus D. So we don't know where is it yet. So we just write R minus D in general. Don't forget squared. Okay, don't forget squared. Okay, now if the resultant gravitational field is 0, so what does this means? E2 must equals to E1. Okay, so gravitational field is 0 at this point. So that means E1 equals to E2. So you equate them. They are balanced. So now you substitute, equate these two. Okay, equate these two. So you can cancel the G and the M and cross multiply. Square root both sides. Easier to solve for D. So square root both sides and cross multiply. So square root of 1 per D squared is 1 per D. And then here, square root of 4 is 2. Square root of R minus D squared, bracket squared is R minus D. So cross multiply, you get R minus D equals 2D. And D equals to R per 3. So the distance is 1/3 of this R. Measured from where? So measured from M. Measured from M. Mention here. So 1/3 1/3 of R measured from M. Okay, don't leave your answer like this. So you write. Okay, so 1/3 of R from mass M. Okay, from bodies with mass M. Okay, so that's the answer. Okay, so these are all the questions that I've given in the PDF question. Okay, so we will continue. This is solving problems part 1 because there's a lot more. We don't have time actually to discuss all the questions in this topic in this class for 1 hour. So we will continue for the next class part 2 gravitation solving problems. So this one, question 9, I didn't give in the PDF question. Also question 10. So we stop here. Okay, where is it? Okay, so that's all for today. Okay, I give back to Madam Hapsayu.
Okay, thank you, Madam Rusmaya. Okay, Alhamdulillah. Okay, we have reached the end of today's session. Okay, thank you, Madam Rusmaya, for preparing today's lesson, and congratulations to those who are able to follow our live class from the beginning till the end. Again, students, let's thank Madam Rusmaya by clicking the subscribe button and activate the icon bell so that you will not miss the next live class, and also don't forget to hit the like button. Okay, the last digit code is number 6. Okay, number 6. Okay, now you have all a letter and 5-digit code. Okay, 5-digit code to claim your credit. Okay, the credit link and the link to claim the credit are already in the chat box. Okay. The certificate and credit link are given as a token of thank you for your dedication in joining the free online class today. And please share today's live class to your friend on your social media. Okay, spread and share the goodness. Okay, please take note the credit link will end 15 minutes while the certificate link will end half an hour after this live. Make sure to use the edu.my or MOE-DL okay, to log in. Incorrect email use will not be entertained. If you wish to get more information on the online class, okay, go to www.academyyoutuber.com. And to those who haven't joining eDidik Junior Telegram, okay, please do so. Okay, so don't forget to join our live class. Okay, next week we don't have, isn't it, Madam? Okay, next 2 weeks.
We don't have class.
Next 2 weeks. Okay, next 2 weeks on Sunday at 5 PM. Okay, till we meet again, ingat hashtag bermula percuma, selamanya percuma. Stay safe and be safe, student. Okay, bye-bye. Assalamualaikum.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
dibawakan kepada anda oleh Akademi YouTuber.